Hey, welcome back to Arithmetic with Ron. Today we're going to talk about how to multiply and divide by powers of 10. What does that mean? And how do we do that with whole numbers and with decimals? I'll show you on today's video. If we're going to talk about multiplying by powers of 10, we're going to have to know what a power is. Power is another term for exponent, and it tells you how many times a number is multiplied by itself. So here, 10 to the first power is just 10. 10 to the second power is the same as 10 times 10, which equals 100. Notice that with 10 to the second power, I'm multiplying 10 by itself 2 times 2, and my answer has 2 zeros. So 10 to the second power is 10 times itself, so there's 2 tens being multiplied, and the answer has 2 zeros. That pattern continues. And so this is what we mean by powers of 10. What these numbers all have in common is that they all start with a 1, and the number of zeros behind them corresponds to the power of 10. How are we going to use this? Well, let's start with something small, like the number 4. 4 times 10 is the same as the number 4 and the same number of zeros that are on the 10. Okay, if you know your times tables, you can take a look at this and say, yeah, 4 times 10 is 40. But we can apply that to bigger powers of 10. Here I have 100, which is 10 to the second power. 4 times 100 is 400. Notice again, it's the same number 4, and it has the same number of zeros as the power of 10 did. If I take 4 times 10,000, I'm going to write 4, and then I'm going to count the number of zeros. 1, 2, 3, 4. 1, 2, 3, 4. There we have it. How about numbers like this? 500. Well, that kind of looks like a power of 10, but it doesn't start with a 1. We can rewrite this as 5 times 100, and now we have our power of 10. So this is like saying 5 times 10 squared, or 10 to the power of 2, because there are 2 zeros. Now, let's do something that's a little bit more difficult. What if I do 2 times 50? Okay? Now, in this case, we can still apply the rule. This 50 is a power of 10, right? It is 5 times 10. So we can rewrite this problem as 2 times 5 times 10. And now we have our power of 10 separated out, okay? But what happens here is our 2 times 5 is going to produce another 10. 10 times 10, and it equals 100, okay? Look at how we have 2 zeros here, but we only had 1 zero behind the 10. What happened? Well, what happened is this first 0 came from the other factors. Had I done this as 2 times 50, I could have said 2 times 5 equals 10. 2 times 5 is 10, and then because there's a 0 here, I can add that 0 on the end, and I get the same answer. Here's another example. 4 times 500. Okay? Well, 4 times 5 is 20. So I'm going to write 20. Then I'm going to go back and say there were 2 zeros on my power of 10, and so I'm going to add 2 more zeros at the end. And here they are. Notice that the answer has 3 zeros. These 2 zeros came from the zeros on my power of 10, and the first 0 came from the digits here, the non-zero digits. So just be careful when you do this that you take a look at the non-zero digits like we did here, multiply those out and write the answer, and then after that's done, you can go grab the other zeros that were left over. One more quick example just to see how that might work. 20 times 50, okay? I can look at this and say I have 2 zeros because these are powers of 10 or multiples of 10. And so I know that at the end, I'm going to have 2 zeros to add. But first, let's do the digits. 2 times 5 is 10. Now I can go back and say 1, 2, so I'm going to add 1 and 2, and my answer is 1,000. So just keep track of the digits up front, do those first, and then after that's taken care of, you can add any zeros left over. All right, how about dividing by powers of 10? What is 500 divided by 10? Okay, when we do problems like this, the easy way is to remember that zeros at the end of a division problem will cancel each other out, 1 for 1. 1 on the top cancels 1 on the bottom, and now I can write what's left over, 50 over 1, which is just 50. This problem could have been written also like this, 500 divided by 10. I like writing them as a fraction because then it's easy to remember that zeros can cancel each other out, 1 for 1. And in the future, when you get to algebra, this same process is helpful. So it's good to start practicing now. Why does this work? Well, if I take the original problem, 500, and I write 500 as 50 times 10, 50 times 10 is 500. How do we know that? Well, we just did problems where we did powers of 10. 5 times 1 is 5, and I have 1, 2 zeros. So 50 times 10 is the same as 500. But if I write it like this, look what I have here. 10 divided by 10, and remember that any number divided by itself is equal to 1. 4 over 4, 5 over 5, a billion over a billion, any number divided by itself is 1. So 10 over 10 is 1, which means I just get 50 times 1, and 50 times 1 is 50. You don't have to break it apart like this every time. It's quicker to just use the rule about canceling zeros at the end. Let's take a look at another example. What about 40,000 divided by 200? Okay? What I'm going to do is use the rule with the zeros. Zeros at the end of the number can cancel each other. 1 and 1, 1 and 1. So I canceled 2 zeros on top with the 2 on the bottom, and now I'm going to write what's left over. 400 on the top, 400, and on the bottom all I have left is 2. And 400 divided by 2 is 200. And you can check that in a calculator if you want. Maybe one more example here. How about 1,000,000 divided by 1,000,000? Well, we already know that anything divided by itself should be 1. Let's see what happens. Look at that. There were the same number of zeros on the top and bottom. They cancel each other, and you have 1 over 1, which is just 1. All right, now that we've looked at whole numbers, let's go back and try this with decimals. What happens if I have a decimal number like 50.15 and I want to multiply it by 10? Okay? When you multiply and divide by powers of 10, there's a great little trick with decimals, and all we're going to do is move it one way or the other, depending on whether we're multiplying or dividing. We know that the answer to this problem should be bigger than 50. In fact, 50 times 10 is 500. So since this is just a little bit bigger than 50, the answer should be a little bit bigger than 500. And if I move this decimal one space to the right, I get 501.5, and that is the correct answer. You can check that in a calculator if you want. And so with multiplication, when you multiply, you move the decimal point to the right. What we're going to see is that when you divide, you move the decimal point to the left. Okay? So let's take that same answer, 501.5, and if I were to divide it by 10, I would say, since I'm dividing by 10, I'm going to move the decimal point to the left one space. And now it's back between the 0 and the 1, 50.15. What we're going to see as we do more examples is that the decimal gets moved depending on how many zeros there are in our power of 10. All right, what is 2.01 times 1,000. Okay? Well, we're multiplying, so we're going to move the decimal point to the right. But how many spaces? 1, 2, 3 zeros means 1, 2. Now what do? We need to go a third space, and so we're going to put a placeholder 0 in here. Okay? So if I rewrite this, I get a 2, 0, 1, 0. This is my placeholder 0. And the decimal point landed after my placeholder 0. This is not the decimal. Let's get rid of that little guy right there. Okay. 2010 decimal. 2010 decimal. I moved it 1, 2, 3 places to the right because I had 3 zeros, and multiply means move to the right. So this answer is 2010. Okay? How about if I pick a big number and go the other way? 410, and I'm going to put the decimal with a 0 just so that you can see where it is, divided by 1,000. Well, I have 3 zeros on my power of 10, so I need to move the decimal to the left because we're dividing 3 spaces. 1, 2, and 3. So my answer is going to have the decimal right in front of the 4. And then we're going to keep the other digits the same. 4, 1, and then you can put both of the zeros if you want to, just to see where you came from. In this case, these zeros at the end don't change the value of the number, so we could write it like this, 0.41. Both of these have the same value, but one of them shows more digits, and that's okay if you want to do that. I encourage people to do that, especially so that you can keep track of where you started and where you ended, and you make sure that you went the right number of places. One more example here. When you divide, let's do a number like 450.0, and we're going to divide by 20. In all the other examples with decimals, this leading digit was a 1, and when you divide by 1, you don't change the value of a number. Here, the first digit is a 2, so we can still use the trick with moving decimals 1 space for every 0, and since we're dividing, we're going to go to the left, and since there's a 0, we're going to go 1 space. I can still do that, and I get 45.00, but now because this is not a 1, we need to keep that, divided by 2. So my final answer, this is really 45 divided by 2, and you can either leave it as an improper fraction, or you can write it as 22.5. So in all the other examples, this first digit was a 1. And at that last step, we would have been dividing by 1, which would not have changed the answer. But if you have something else, let's do another one, 450.0 divided by 300, okay? I can move to the left 2 spaces because I'm dividing, so move to the left, 2 spaces because I have 2 zeros. That would give me 4.500. But now I'm going to divide by 3 because that leading digit is a 3. In all the other cases, like I said, this was a 1, and so dividing by 1 doesn't change anything. But here, we still have to divide by 3, so this is 4.5 over 3, and your final answer would be 1.5. So just be careful that when you're doing these problems, if the leading number is not a 1, you can still use the trick with the numbers and the zeros, but you have to include that final first digit at the end. So today we took a look at how to multiply and divide by powers of 10. We talked about what it meant, and we showed both whole numbers and decimals and how that whole process works. Hope you enjoyed the video. Go ahead and send me any comments, and we'll see you next time.